Hello, everyone. Thank you for joining the Network Access Fundamental Security webinar for U.S. courts, a collaborative learning event brought to you by Cisco and Ironbow. My name is Kerry Blackstone. I'm an account executive here at Ironbow, and I'll be your host for today's session. Over the next 45 minutes or so, we'll discuss the importance of network access security, its relation to zero trust, along with some real-world use cases. Let's get things kicked off by getting to know our panelists a bit. So to my right, we have Corey Jackson. Corey, thanks for joining us today.
Glad to be here.
Appreciate it. So Corey's got over 20 years industry experience working at companies such as Force 3, which is now Sears Federal, Presidio, and GuidePoint. Corey now runs the Ironbow's security practice, where he works closely with customers within federal, SLED, healthcare, and commercial verticals. To Corey's right, we have Paul Lucas. And I want to make sure I get my right and left down, so we're in good shape.
That's Kerry.
Paul, thanks for showing up today.
Appreciate it. Thanks for letting me.
I didn't have to pay you, right? So we're good. Paul's had a very successful career at Cisco for over 28 years as a consulting solutions expert. Paul has worked closely with various federal agencies and service providers. Paul is at his best when working with customers and aligning with their mission. Paul, thanks again for joining.
Appreciate it. Thanks for let me be part of the team.
Yeah, absolutely. Last but not least, we have Ryan Harrington. Ryan is out on our West Coast in San Diego. Ryan, thanks for joining.
Yeah, glad to be here.
So Ryan joined Ironbow a couple of years ago as our Director of Federal Strategy after 9 years at Cisco. During his time at Cisco, Ryan supported the U.S. Navy as a solutions architect and as a business solutions architect. Ryan helped to define Cisco's federal strategy while supporting a large-scale transformation efforts across all the federal government. At Ironbow, Ryan works closely with federal customers to align the mission and business value of federal agencies to the adoption of technology. With that, let's get things kicked off. So what we're going to go over today and what we would like you to learn is a little bit about zero trust, if you don't know so already, and how things have evolved, how we've done some things in the past, and how they've evolved to what we'll be talking about today, and what exactly is network access control, or NAC, and a little bit how this blends in with some of the requirements and areas around the judiciary IT security scorecard. With that, Ryan, you want to kick us off here?
Yeah, perfect. So just wanted to start here with a little bit of the foundations of zero trust. So zero trust is a bit of a buzzword that's been floating around forever. So just wanted to start by demystifying this a little bit. So just for everyone's awareness, right, the concept of zero trust isn't anything new. It's been around for a while. It's just kind of been formalized with guidance over the last, 5 to 8 years. Back in like 2004, the Jericho Forum first kind of started off by bringing the concept of deperimeterization to networking and security. So the foundational concept of zero trust is really around the concept of cybersecurity and the challenges that perimeter-based security model brings into the organization by assuming that no device or user inside or outside of the network should be automatically trusted. So the core concept here, the core principle is never trust, always verify. And we do this in a couple methods. The first being by continuous authentication and authorization of every user or device attempting to connect to the network. As we do that authorization and authentication, right, we put down a strict set of access control rules that are enforced across the entire environment based on the level of access. And probably the most important part is the continuous monitoring of those devices and those users, checking for any abnormal behavior, any malicious activity that is conducted across the network. So this approach aims to enhance security by assuming a breach is possible and taking all the proactive measures to minimize the risk and protect our sensitive data and systems. So here on the slide, you'll kind of see some of the three fundamental areas of zero trust. The visibility we'll talk a lot about today really focuses on, who is that user and device and how are we granting them the right level of access onto our network. The second piece is segmentation and it's really focused on shrinking the attack surface across the network. A great example of this is a couple years back, Target got hacked. The hackers actually jumped in through the HVAC system and somehow were able to jump over to the credit card system and be able to pull a lot of credit card information. If we had segmentation brought into the network, we would actually minimize the attack surface. And by hacking in just to the HVAC system, they wouldn't be able to hack or jump laterally into the credit card system. And the last piece is really focused around containment. Once we have that visibility and really understand, the user's access rights and privileges, it's about leveraging automation when we notice something is abnormal or malicious to be able to revoke their rights and privileges, put them into quarantine areas, and get the infected endpoint off of the network as quickly as possible. So with that, I will pass it back over to Corey to talk a little bit more about Zero Trust.
Okay, thanks, Ryan. So we're talking about Zero Trust today, and we need to kind of level set for individuals that maybe aren't familiar with the CISA Zero Trust maturity model. So let's kind of take a look at the 5 pillars and talk about those, explain those, and then we'll get into how that relates to network access control. So when we're looking at the CISA pillars as displayed here, we have 5 pillars and we have 3 fundamental cross-functional capabilities as well. So at that foundation, we have governance, we have automation and orchestration, and we have visibility and analytics. And the reason those are fundamental and foundational, those are relevant to all of the other pillars above them, right? So that's why they're represented there. You may see some other Zero Trust maturity models like from the DoD, where those are broken down as pillars individually as well. But suffice to say, it's consistent across all the models that those are all relevant. And then if you look at the pillars, you'll see how they're organized from left to right. And in cybersecurity, we're typically most concerned about protecting our data, right? So we have all of these controls and capabilities to the left that basically come before our data and protecting that. So when we start with identity, because identity is critically important, because once we have identified that end user or that device, that's when we can start using that identity to apply to policy, whether it be on the device, on the network, or within the applications, and controlling the access to that data. So what we're going to be discussing further is Identity Services Engine and how that relates to network access control and how it's relevant to Zero Trust. But we see we're starting with identity, right? So identity is in the name of the product. Identity is that critical first pillar that we need to get established, and we have to have that as a solid foundation to be able to start applying security policy across the infrastructure.
Thanks, Corey. Hey, Ryan, with all the customers that you deal with on a day-to-day basis, how are you seeing them, address not only Zero Trust, but aligning with these pillars in their various environments?
Yeah, great question, Kerry. So I think the first thing to kind of focus on is, these different Zero Trust models that are released, whether it's NIST or CISA or DoD, are really frameworks and points of guidance on how to approach Zero Trust. They don't get down into a lot of the details on how to implement it and defining a roadmap for building it out. So, one of the first things I see a lot of agencies doing is really taking a little moment to self-reflect and assess their maturity of where they are. Defining what compliance associated with Zero Trust means to you as an organization, and understanding where you are at this point of time, and what are the key priorities you need to focus on in order to start, enhancing your journey of Zero Trust. Associated with compliance is also, in the CISA model, they build out foundational, advanced, and optimized levels of maturity in Zero Trust. So associated with compliance is defining, what level you're trying to hit. What are the key capabilities you need to enable? And are some systems or applications or devices requiring a higher level of maturity than others? And so hitting that compliance is key. One of the things we see a lot of agencies doing is actually going through tool rationalization. And they go through this in a couple different ways. One is, how do they map up to the maturity model? based on the tools they have. Do they have tools that are doing the same capabilities on the maturity model? And they need to look at maybe decommissioning and fully utilizing the investment in existing tools to a fuller capability. The second is what I like to call a turn it on campaign, and it's really focused on leveraging the full investment of the tool sets that you have today to start matching up against that zero trust matrix and level of maturity. Another thing, I always like to know is there's a lot of architecture out there that says, every OEM can do zero trust, but I think it's critical to note that not any of the OEMs can do all of zero trust. So my last point is, because no one can do all of it, it's really about building this ecosystem of cybersecurity products that work together, that can share context and share data, and enforce policy based on this actionable insight that they're seeing across the environment.
Great. Thanks, Ryan.
Okay, so like Ryan was saying, Zero Trust isn't just one product from one OEM. And this diagram that comes from the NIST Zero Trust Architecture publication, I believe it's 800-207, kind of highlights that. So we have a lot of different systems that are feeding into this policy decision engine that we have here. So, in this scenario, we have a policy decision point. So we have a system that we're using to configure to make our security policy. And then in that data plane below, you see we have a policy decision point, or a policy enforcement point. So taking those decisions that we created in the policy decision point and then pushing them down to be enforced on systems that are trying to access data. So in a moment, we'll go to the next slide and you'll see how this maps to Cisco ISE very closely. So you see here, we have all those same inputs, and that policy decision point is now Cisco ISE, right? So that's where we can configure our authentication policy, our authorization policy, and we can create all of our different conditions for like profiling endpoints and doing endpoint security posture, right, Paul? And then you see that we have something called a supplicant, right? And it sounds complicated or fancy if you haven't already seen it, but it's a supplicant is basically just a client that allows your Windows endpoint or Mac OS endpoint. Pretty much every modern operating system has a supplicant built in. Cisco also has their own supplicant you can use if you so choose. But that's what allows that identity from that end user and the device itself to be transmitted to the network switch or the wireless LAN controller, whatever happens to be used at the moment. That access device now becomes your policy enforcement, right? So you can start to enforce security policy on the network, on your access layer switch or your wireless LAN controller. But that identity from the user and the device is forwarded to the switch. That information is then packaged up in a radius packet and sent up to ISE. ISE uses that information to be able to make that authenticate that user and the endpoint. So we have like two authentications that can happen, right? So we have a valid user on a valid government furnished device, let's say in this circumstance. So if all those things are good, then we can authenticate them. And then we have to determine, once we've identified that good user on a GFE device, what should they be able to access? Well, that happens at the policy decision point on ISE. And that information gets pushed back down based on whatever the result is, once again, in another radius packet back to the access layer switch or the wireless LAN controller. And that's how we make a determination on who should get access and what they should get access to. And that allows us to protect our data.
So Corey, this is a big shift from the US courts model today, where they pretty much do static mappings on the port. This port assigned to this VLAN allows these privileges. Again, so what would the IT directors and the IT personnel at courts have to do at that access level port to allow port-based network authentication?
So it's going to be a combination of .1x and radius configuration on that network device. And of course, we need to have the ISE deployment infrastructure there for it to be able to talk to. But as far as the integration, it's radius communication. So it's all things that already exist on the access layer switches and controllers they already have.
And if the device doesn't support 802.1x, they do have other options, correct?
There are other options. 802.1x is ideal, but there are some other mechanisms we can use to get some of that identity information to be able to make some of those policy decisions.
Great.
Okay. Like the dialogue.
Yeah, so I just kind of wanted to drill in a little bit here on, as we're pushing those policy enforcement points and we're pulling together the information we need to actually make that decision based off identity, traditionally, this has always been done off of IP addresses like you see on the left and MAC addresses of the device. And it doesn't really tell us too much information about the user itself. It's all based off that number of an IP address and a MAC address. So what we're trying to do here is get a lot more visibility and rich context to give us more granular control of our environment. And so if you look here on the right, if we can understand who that user is, what type of device they're connecting with, where they're coming in from, whether on campus, at a remote facility, they're coming in completely remote from a Starbucks or something, that should drastically impact the amount of rights and privileges we can give them. So this rich visibility and context really allows us to have more granular authentication policies, allows us to differentiate the rights and privileges we give to different users and devices based on their location and their access privileges, and also allows us to build in segmentation into our environment based off of all of this rich context.
Thanks, Ryan.
So how have we historically dealt with some of these challenges, right? So the problem, as somewhat stated before by Ryan, is that our security controls traditionally were at the perimeter, right? We had firewalls, we had IPS, IDS, we had a bunch of different technologies protecting our campus and our data centers from the outside world. But once you were on premises, once you were in the campus or in the data center, it was pretty much Wild Wild West, right? And then once you're on premises, well, if you don't have any controls internally, any potential zero-day attack or any malware can pretty easily spread throughout the network, right? Because we didn't typically have those controls internally. And that leaves us susceptible to insider threats as well, because we're not tracking the identity of those individuals and what data they're accessing because we simply didn't have the visibility. And we are coming up with more compliance regulations that organizations have to adhere to. There's more governance that's being required of organizations that's requiring having these controls in place. And we have to do all of that and raise the level of security on premises, at the campus, really everywhere, but still try to maintain a positive workforce experience, right? We don't want to burden end users with really cumbersome software on the endpoint or just a lot of different prompts and nag screens and that sort of thing. We want to have as seamless of a workforce experience as we possibly can while raising the level of security internally. So how were we doing some of these things before? So we started out, in the olden times, and still, I'm sure we have customers that are still doing it today, right? Just doing traditional port-based security. Port security with MAC address sticky, right? The guys in the NOC and the folks that are operators of the network devices, they're probably very familiar with this already. And if you had some sort of findings around network access control and you didn't have a network access control system in place already, this was kind of the stopgap, right? So what are the pros? So it's relatively lightweight and easy to implement, right? We don't need any additional software. All you have to do is log into your network device, put a couple of commands on the port, and then you lock down that one particular port to a particular endpoint. The challenge with that And the cons that come with it are that now we've got this like inference of just a MAC address and maybe the associated IP address, but that's all we know about that endpoint. And that endpoint is just tied down to that one particular port. So while we may have raised the security posture a little bit, because not anyone can connect to that port now, it's just a particular endpoint, we still don't have any visibility because we don't know who the actual user is that's using that endpoint, right? That doesn't really scale, because as soon as someone takes maybe that printer or that IP phone that's plugged into a port and goes to move to another port, well, the port's going to error disable, right? And it requires just a lot of care and feeding and maintenance from the network operators to basically keep the network up and running when you have port security on all the ports, because any move or change that happens, someone has to log into the switch to be able to basically make it continue to work, right? So at the end of the day, it's a stopgap, but it's not really getting us to zero trust, right?
Yeah, understood.
Imagine that, maintaining those MAC address tables in a large enterprise.
I've done it before in a prior life, and it's a pain. It's a whole lot of trouble tickets and a lot of management effort for relatively little return from the security aspect. So after the port-based security, we have legacy NAC solutions. So Cisco had a legacy NAC solution 20 years ago or something like that, and many vendors still operate with NAC solutions that are kind of operating in this legacy model, right? The advantages now, great, you have a central management platform. You get a little more visibility because it is centrally managed. You have communication with all these network devices. But there are a bunch of cons that came with it. And one, most of these systems were pretty clunky. They were probably pretty highly dependent on a proprietary client application. To talk to network devices, they usually required SNMP traps. And so SNMP traps are really for network monitoring and that sort of thing. It's not really designed for that particular use case. So we were taking a technology that wasn't originally designed for that and kind of making it conform and making it work for this particular use case, but it definitely wasn't ideal. So you had network devices sending traps to a NAC system. You had the NAC system sending traps back to try to authorize ports and that sort of thing. And so their state wasn't managed very well. And you would run into a lot of issues just around ports being out of sync with the NAC system. And then if you wanted to have the best security efficacy in those sorts of systems, then you had to have a physical appliance that was in line with your access layer network. So that created additional points of failure and made the network just that much more complex, right? Because then you had appliances that you had to insert in line. Of course, if you're adding more servers and more compute, you're adding more cost, right? So it was relatively costly as well. So, just a situation where these legacy NAC solutions are just far from ideal. Most customers have moved away from them, and they're using more modern solutions like Cisco ISE that are based on Radius.
Yeah, I was going to ask you guys have seen if any customers are still using this implementation or not.
No, we're starting to see more and more, like you said, migrate toward the network access control and policy enforcement type of a model.
Yeah.
With ICE and other vendors that are out there, but they really are moving away from the legacy NAC solutions.
Yeah.
So when we talk about network access control, Ryan had touched on it earlier, right? There's a lot of buzzwords and a lot of people, use terms interchangeably. You'll hear defense in depth. That's more though, as you had mentioned, it's the network perimeter, right? It's looking at it from the outside coming in, not so much that I'm an insider threat, right? It's really trying to protect from the outside. And, it looks at the network in a way that, from the endpoint and through traditional firewalling, et cetera. It is a strategy. It's a way to protect. It's a strategy. It's not an overhauling architecture, but it's a strategy. And there's just, there's multiple areas there, multiple measures that you have to implement to deploy that strategy. On the other side of the house, you have your zero trust. And I think that is more geared toward what we're seeing from a court's perspective, and what they've laid out in their scorecard is an approach where we take the network, but we're expanding it both to then now to the devices and also to the identity. Really what zero trust is saying that, look, it's like an implicit deny in an ACL world, right? I'm denying all access to this network. That's what the zero trust model is. It's denying all access until you prove your identity, and then based on your identity, we'll give you access to resources.
Gotcha.
So back to the scorecard. There were three key, when I went through the scorecard, I really looked at it, and there were three key metrics that they identified. Network segmentation, reduce your attack plane. And that in segmentation, right, by you implementing VLANs, now you're, reducing broadcast domains so that if somebody did infect the network, they would be limited to that particular VLAN in itself. But again, the idea there is that the user still gained access to the network, right? If it's not based on his identity, I could plug in my laptop and infect the network. They didn't verify my identity before I connected. I was granted access. Then the next is ACLs, right? Traditional access control lists, where you limit protocols and ports, north, south, east, west traffic. But again, you're on the network. You already have access to the network. But the one key metric that I saw that really aligned to a zero trust strategy was the one about policy enforcement. Now, this is where I see courts migrating away from the traditional configured static VLAN port to identity. My identity now will go with me wherever I go, and I'll be authenticated on whatever network connection I make, whether it's wired or wireless. So that's where I see that the court's scorecard is asking the courts to align to that strategy. Now, what we have to also consider is that the IT staff at the courts, they're not just sitting there watching the network all day. They wear multiple hats. They manage the courtroom, the IT infrastructure. They deal with the judges and everyone else in that courtroom. So what we want to do is, make this simple, make this transition simple.
Yeah.
And with you guys' help, I think we can show them, not only the why, but the how.
Yeah, no, that's good, Paul. Ryan, on that topic, I know you've done some work on the transformational roadmap in partnering with Cisco. This kind of evolves from what we're looking here to help out the courts, correct?
Yeah, correct. So, the point of the transformational roadmaps are all about taking the business goals and objectives that they're trying to achieve and aligning technology and the adoption of technology to it, right? So it's in terms of the scorecard, it would be assessing an as-is state, where they're at today, and building towards a to-be state with, a sequential technology adoption roadmap built into that to get them to that state. Now, throughout that process, there's a combination of, as we mentioned earlier, turning features on, right? How do we leverage the full investment of what the courts have already invested in to actually turn capabilities on, to check those boxes based along the lines of the business, and then creating a roadmap of maybe new things that need to be done, right? New product sets, new feature sets, new capabilities, even new integrations that need to be done to be, getting that scorecard closer to the 100% accurate. And so the point of the transformational roadmaps is really about that as is and to be, building sequential, stepping stones and milestones throughout the process to show progress and impact kind of the quality and the total score on that scorecard.
Great. Yeah. Thanks, Ryan.
All right, so we've been talking about zero trust in general as a concept and some of the other concepts, but we'll start to get more into the building blocks that actually allow us to implement zero trust technically. So network virtualization, once again, this is focused on the network pillar. It's in the name, right? So once we have all that identity information from ISE and from the endpoint, and it's been provided from the switch to the ISE deployment, there are certain things we need to do on the network side to be able to implement segmentation, right? And the beautiful thing about ICE is that like this segmentation that we're talking about here, this is relatively broad. It's, I guess what we would consider macro segmentation, right? When we're talking about breaking out different VLANs and VRFs and that sort of thing. But the information we get from ICE allows us to do differentiated access and allows us to use some other capabilities that we'll go into in a little bit to get to that micro level of segmentation. But going back to the segmentation here, so we talk about VLANs already, and most of you are probably already familiar with what they are, but we'll just kind of prime that here as well. So VLANs are a virtual LAN, so that's a layer 2 forwarding domain. So that's going to be relevant on our access layer switch, where we would traditionally use VLANs to separate different types of devices or lines of business or parts of the organization, those sorts of things. And that level of segmentation there on the network allows us to at least limit the broadcasts to that one particular virtual network, so that devices, whether it be laptops or headless devices, whatever it is, can communicate in that VLAN, that one virtual LAN, and they're contained there. And in order to speak to anything outside of that network, they would need to be routed out. And so on those routers that they would be talking to, we have another, virtualized segmentation concept, and that's called a VRF, a virtual route forwarder. And that's essentially allows us to create individual little routing tables, right? Virtual routing tables within our physical router, our physical network infrastructure that are either separated by different lines of business or different parts of the organization and that sort of thing. And then we can stitch those VLANs and those VRFs together where appropriate to be able to create essentially virtual networks on physical infrastructure, right? So we could have different organizations using the same physical hardware, but having separate virtual instantiations of those technologies on the physical hardware. So are the courts using any of these technologies, or how are they using them?
Yeah, these techniques are foundational to courts today. In most of the courts that I've visited, they have a collapsed core architecture. They have an access switch, access layer, and then a core layer. At the access layer, they're implementing VLANs. And then there's a term called combined courts model, where within a single courthouse, there can be multiple courts. And they implement this technique where they actually can, now at that core switch, they create 2 or 3 different VRF instances, which are logical routers, that would allow a tax court or a probation court or a circuit court all to run in ships of the night of each other. So they're traversing the same infrastructure, using the same uplinks and trunks, but they have no ability to interact with each other. They're 3 separate networks.
Gotcha.
Makes sense.
Paul, that RIP routing process certainly takes me back. Is that something that you can still configure, or is that?
No, I think RIP has evolved to rest in peace for that particular routing protocol.
Yeah. Okay, so we've talked about a bunch of different components and parts of a zero trust network architecture. So starting with the identity, we can identify who the user is, what group memberships that user should have, and what type of device they're connecting from. Also relevant to identity is not just users on a laptop or workstation or something like that, but we have all the other IoT devices that are out there on the network, right? We have the IP phones, we have printers, we have building management systems, we have IP cameras, those sorts of things. We need to be able to allow those devices onto the network, right? And we have our switches, our wireless controllers, VPN concentrators, SASE and SSE technologies as well that provide the access, right? That's that network layer of the zero trust architecture, or that network pillar. And we're using Cisco ISE to automate and orchestrate all of that in this example. So, going back to our fundamental pillars, ISE has a participation in that as well. It's providing that identity use case, it's integrating with the network pillars as well, but those fundamental governance, automation, orchestration, visibility, we're getting those capabilities from ICE. And ICE has to integrate with an identity system. Typically, it's going to be Active Directory or LDAP, and we can integrate ICE with a SAML 2.0 provider as well. Also, mobile device or endpoint device management systems. So whether it be any number of vendors, we can integrate there as well, so that in the use cases for like BYOD devices, those sorts of things, or maybe just government furnished mobile devices, we can use the state of that device and the information on it. Like, all right, we can allow that iPhone to access resources if it has the PIN of 6 characters enabled and encryption is enabled on the device and all that sort of stuff. If that's enabled, we can use that in the authorization decision within ICE to be able to allow it to the network or determine what level of access that endpoint should get, right?
Corey, today, the administrative office of the courts, they have a centralized ICE deployment in their 2 data centers. They, centralized AD for identity, username, passwords, et cetera. But they use this for their nationwide guest wireless access. So this is a service that AO provides, and ICE is the fundamental identity engine for that, to identify users and on the network.
Okay, that's good to know. And I kind of going back to a previous point where we were talking about how things can be ships in the night, and we can have those separate VLANs and VRFs and segment that traffic and everything. That allows us to be able to support that guest use case as well on the same hardware, potentially, if the government or the organization is willing to, accept that. That's a capability we can provide too. So once again, providing a positive workplace experience, but still being able to provide a high level of security efficacy as well.
Seamless connectivity, that's what everyone wants.
Yep.
Yeah.
So we were talking, and we have been talking kind of at a high level about some of the capabilities, and this just kind of illustrates what we can do with the authentication and authorization of ICE with respect to differentiating access. And I've said it a couple of different times, but differentiated access means we can provide the appropriate level of access for users based on their roles and their group membership. So in this example, for the courts, we have a judge and a court clerk, and they're presenting their identities, and that identity could be based on a username and password, or it could be from a certificate. ICE is flexible. We can integrate with either and use either. And we can also use the identity of that device they're connecting from too as well. And we can use both of those in that authentication and authorization decision, right? So the judge may be using a government furnished laptop, and so they're able to access all the information they need to with that. But if that same judge is maybe using a personal device or connecting from another non-friendly country or something like that, maybe you limit their access, right? Because maybe that's not appropriate for either that location they're connecting from or the device that they're using to connect. It may not be appropriate for them to be able to access that data, right? And we can do the same thing for different personas and different roles, like a court clerk or something like that, that maybe you should have a lesser amount of access. We can limit that access for that individual, once again, based on the device they're connecting from and the locations they're connecting from as well.
So Corey, you mentioned IoT devices earlier. We've seen in other networks that people have IoT devices that aren't 802.1x or MAB capable.
Right.
How can then courts not only detect those devices but also classify those devices? How can ICE help us in that regard?
So ICE can integrate with the other third-party systems that may be managing some of those devices, be able to glean information from those systems to be able to make a authorization decision, like, is that particular device in the organization's configuration management database? If this is one of our phones or one of our cameras or something that's in one of our integrated systems, we can provide access to that. But maybe if we see the same model of IP camera that's not in our database, we wouldn't permit that onto the network, right?
So we could kind of quarantine it off and put it to the side until somebody takes some user action to authorize that device onto the network.
Absolutely.
And then how about security policies, right? We see this in
Yeah.
other areas where companies have security policies that you have to maintain. Your end device has to be, Chrome has to be a certain version of Chrome. You have to have a certain, whatever your authentication device is, as far as whether it's Duo or something else. How do you have compliance? How do you ensure compliance?
Right. So we can do some of that compliance management by using the posture assessment capabilities device. So that's a situation where if you want to see detailed information about the endpoint, we can do that interrogation either using a client, and there's some things we can do clientless as well, on like a Mac OS or Windows endpoint, to be able to assess like what service pack and what patches are installed on that endpoint. Are they running anti-malware software? Is that software up to date? And are they meeting other organization compliance requirements on that endpoint? And we can differentiate the access once again based on the security posture of that endpoint. We can allow just enough access for those issues remediated if it's that endpoint's not compliant, or if it's like, let's say, once again, a BYOD device or something like that we can't get that information on, or maybe we don't want to interrogate that. We can still provide access, but the appropriate level of access for that particular device. So we've been talking about enforcement options, and we were talking a lot about VLANs earlier because that's one of the traditional methods that a lot of people are probably already familiar with. And we actually gained some additional flexibility with that VLAN enforcement, because one nice thing about using ISE for authentication and authorization is that now we have the capability to make those switch ports more dynamic. So no longer would you necessarily have a situation where, this particular port is configured for a phone, or this particular port is configured for user access or for a printer. And if you plug the wrong device into the wrong port, well, it just doesn't work, right? Well, we configure our ISE policies such that once that printer is recognized, well, that becomes a printer VLAN. And if we recognize that it's a valid user with a GFE laptop and a valid user, that port becomes a user port now, right? So that allows us to orchestrate the network provisioning, really. And so that's not necessarily a security use case. That's more of a network operations use case. But that's another situation where we can use ISE and use that orchestration and capability to be able to relieve some of the burden from the network operators, right? They no longer have to go and configure each individual VLAN on every single port. And also they don't have to do the cumbersome port security stuff, right? So that's something that frees up the NOC to do a lot of other things they probably would like to be doing and need to be doing, but don't have time to do right now.
And last August, I attended down in Louisville, Kentucky, the U.S. Courts Conference. And one of the number one concerns were their access ports, right? There they are, and whether it's their own dedicated closet or a shared closet, they were nervous about the ability of someone to be able to walk into that closet, plug into a port, and have access to the network. Now with dynamic port authentication, right? This gives them the ability that if that person's not identified, whether it's an IoT device or a laptop, et cetera, if they're not authenticated, they're not getting access to the network.
Exactly. And then we have access control lists. So typically people think of access control list in the context of like firewalls and that sort of thing. But we can use ACLs at the access layer. And we can use ISE to be able to provision that and orchestrate that as well. So whether that be pushing down a dynamic access list, so actually configuring an access list in ISE, and pushing that down to the network device. There's intelligence in the network device to be able to make a substitution to understand, what the IP address is of the source coming from that port. So, you don't need to configure the IP address of the source and that sort of thing in that dynamic access list. Or we can use named access lists, so essentially an access list that's already configured on the device, and we just kind of reference that in the authorization decision within ICE.
So you're saying that when that user plugs into, he moves from one building to the next building, and he plugs in and he gets authenticated and his identity is known, his access control list, it follows with him to that port?
Exactly, as long as that user is, that and those switches are configured and talking to the same ICE deployment, whatever policy was on one switch will follow them when they plug into a port on another switch. And then the last technology we have are security group tags. So security group tags have been around for a little while. They've been typically thought of as a Cisco technology, but they are standards-based. They are supported across many different network and security vendors. So we can use those tags in TrustSec in making policy decisions as well, and carry those tags throughout the network, once again, on Cisco equipment or other vendors' equipment, and then also enforce policy based on those tags, either on access layer or data center switches, or even on firewalls. And once again, third-party firewalls can use those tags as well to enforce policy.
So security group tags, I mean, that's a great feature. So Paul, question for you. When I see this, normally it goes along with a software-defined access discussion, or SDA. Is that required, or can I deploy it by itself?
No, you can deploy it by itself. You don't have to go through the whole SDA underlay architecture. You can deploy on this existing architecture.
Okay.
And turn on those features, and those tags will propagate through the network to provide, that micro segmentation.
Okay. Good to know.
So we've been talking a lot about ICE, and I believe there are going to be future sessions where we get more ingrained and in detail about capabilities and features within ICE. But before we wrap up here, I did want to introduce folks to just ICE, the architecture of it, and how ICE deployments work at a relatively high level. So ICE can be deployed on a single server or on a 50 server distributed deployment, depending on what's appropriate for the environment and what the scaling requirements are and that sort of thing. And in every ICE deployment, we're going to have certain personas, and there's one kind of outlier that's going to be situational. So we have the policy administration node. So that's that policy administration point that we were kind of looking at earlier in the NIST zero trust architecture. So that's where we're going to do all of our policy configuration in ICE. We're going to make our authentication policy. We're going to make our authorization policy. We're going to configure all the different network devices we should be able to talk to. All of that stuff happens on the policy administration node. And every ICE deployment is going to have at least one of them. You can have two of them for redundancy. And then we have our monitoring troubleshooting node. That's the node that does all the reporting and logging in an ICE deployment. Once again, every ICE deployment is going to have one of these, at least one of these nodes as well. You can have two of them for redundancy. And all of those logs and things you would need to look at when you're troubleshooting an ICE deployment, you would see it there. Then we have the policy services node. That's that policy decision point that the network devices talk to, whether it be a switch or a wireless controller or what have you. And it's going to communicate with those devices using radius or TACACS. And then we have the PX grid controller, which is what we typically use for those external integrations with either third-party or other Cisco systems to either provide that identity information that ICE has learned to those external systems, or to be able to take information in to be able to use for authorization decision, like for like a vulnerability management system may be integrated with PX Grid, so we can use some of that vulnerability information in our authorization decisions in ICE.
Corey, that's a really important aspect of this architecture. Over the last couple of months, Cisco acquired Splunk. So now Cisco is no longer just the network plumbing, right? We now are really focused on it. So what you're going to see is with this integration is a shift toward AI, but now the ability to tie together with telemetry data, not only from the security side, but from the network side, and have customized dashboards so that at courts, they will be able to look at their network in the way they want to look at their network and how it's performing. So this is an exciting area. Not only ICE will not only act as an independent identity, policy enforcement point, but all of that data now will be collected, and AI will be able to tell you what's going on in the network. It'll help you in the event that there is any kind of malware or any kind of day zero attack. They'll be able to take snapshots of the network. For example, the idea is a ransomware attack that you can snapshot your network once you detect it and recover quickly.
Yeah.
And just take everything, wipe it, and recover. Have a snapshot of your network. So this telemetry data and integration with PX Grid and Splunk, exciting times in the world of security.
Right. And we absolutely had to say AI. We probably wouldn't have walked out of the building if we didn't.
That was the buzzword. That look, we waited to the last slide. To
Yeah,
use that
we got to the end.
Okay, great. So this is towards the end of the discussion here. So, I mean, in summary, we kind of put some things together and did some research on the judiciary scorecard and try to put enough information for U.S. courts to become a little bit more educated on what's available and what can be done and how some of these areas can be addressed.
And actually, I'll take the first one there with the scorecard, right? I think that we have the foundation for the network. Now what we're going to do is expand out to the other two pillars with devices and also the identity. That's where we talk about the 802.1x, MAB, et cetera, to be able to turn on those features and provide that next level of security.
Yeah, I believe there's going to be more conversations with the courts about this, right? So this is just the kind of the introduction or the primer to ICE. And I'd just like to take the opportunity to extend myself and my team's availability to the teams at the courts if they have questions or around ICE, either getting ICE deployed or expanding their ICE deployments or using new use cases within ICE, to reach out to us for that.
I'm definitely going to leverage your expertise to demonstrate the how, right? Like I said, we did the why today, but we really want to go through the how.
Yeah.
And make it easy for them to understand.
Ryan, any closing remarks?
No, I think I'm all good. Other than the fact that great introductory session on how kind of ICE and network access control really hits on those first three pillars in the zero trust model matrix and really starts to help in that maturity throughout the process of starting to adopt the strategy around zero trust, right, and leveraging their current investment to its fullest capabilities. So appreciate you having me on today.
Yeah, thanks, Ryan. So we're going to open it up for questions now. All right, so boy, I got quite a few here. Let's see here.
Wow, we've got some in-depth questions.
Yeah. Let's see.
Yeah, so hit us with the first one. We'll do our best.
Trying to pull it up here. How does Cisco ISE enforce access policies based upon user roles?
So ICE is typically going to be integrated with Active Directory or LDAP. And also typically those users are going to be organized into groups in those directories. And ICE can import those groups and the user association with those groups. And we can create authorization policies based on those groups. So maybe, in the circumstance of a court clerk, they would have access to different databases and information, and then different other individuals in the organization based on their group membership, we can control their access using all the things we kind of displayed. So assigning them either different VLANs or different ACLs or security group tags, we can use all of those in the results to be able to differentiate based on the group membership of the users.
Okay. So we have another one here. What are the key steps for ensuring endpoint compliance with Cisco ISE?
So endpoint compliance, that's going to come down to the posture assessment of the endpoint. So ICE posture is where we do that interrogation of the endpoint to be able to determine what software is installed on the endpoint, what's running, and those sorts of things. So there is an ICE posture module for the secure client to be able to provide that information. We can also get some of that information from an MDM system, something like a Microsoft Intune. And there are some capabilities to be able to have the ICE policy service nodes actually reach out directly to an endpoint and be able to log into it and gather some information there as well.
Okay, thanks, Corey. The next one I see, so how can Cisco ISE integrate with third-party security solutions? I think we might have hit on that a little bit during the session.
Right. So typically those integrations are going to be with the PX grid controllers and deployment. They can be redundant in the deployment as well. You can have a couple of those, but that's usually going to be the integration point with external systems.
Okay, gotcha. And let's see, the last one I see, does ICE fall into the CISA identity pillar along with MFA?
So it does. So it is identity services engine. So it definitely falls squarely into that identity pillar, even though it does touch the devices and network as well. So, there is some bleed over into multiple different pillars. And like I kind of discussed before, some of the foundational elements of Zero Trust. So it covers a few different use cases there. But like Ryan said at the beginning, there's no one vendor and no one technology that is Zero Trust. If you hear that from a vendor or anything, kind of run away.
Yeah.
Don't believe it.
Yeah, don't believe the hype, definitely.
Corey, I have a question for you.
Yeah.
As I mentioned earlier, the IT directors at each one of these courts, they're busy day to day. If you were to go and sit down and talk to them and they ask you, how am I going to deploy this? I can't afford to come in on a Friday night. I'm short staffed. I turn this on, it doesn't work. How do I start? And how do I turn this on without breaking my network?
Right. That's a good question. So every successful ICE deployment I've been a part of has been a phased deployment. And there's a feature on specifically on the wired network where it's kind of more critical and more challenging to deploy a network access control system. Cisco switches have a concept called open mode, where we can do all of the authentication. We can run through the authentication and authorization policy in ICE on the real live network and see what would fail and what would authenticate successfully. And we can work on remediating those things while the network's still in operation without impacting the end users.
So we can actually watch the authentications but not enforce.
Correct. And that's pretty key to being able to have a successful deployment, because we want to go, like I said, in a phased approach where we do the initial integration. We start doing that kind of investigation in open mode where we get all that visibility. We see essentially what's broken, what would not authenticate successfully, and start devising ways to remediate those issues. And it typically moves pretty quickly once we deal with that core group initially in the pilot phase, and then we can usually move on pretty quickly to a widespread enterprise deployment.
And that could be your non-intelligent or non-IP 802.1x scanners, any IoT devices, legacy laptops, et cetera, correct?
Right. I mean, typically the challenges and the things that take the most time are just working with the organization to figure out how they want to handle all these different situations and exceptions, right? They may not have had this type of technology before to be able to enforce policy. So decisions have to be made about how they want to handle those different exceptions and what they want to do in all those different scenarios where they need to differentiate the access.
So the open mode gives them time to think about it and really kind of devise a strategy.
Exactly. Because at any one point in time, that doesn't necessarily represent what your network looks like all the time, right? So you need to have that network in open mode for some period of time to be able to see all the different endpoints.
Yeah, the teams out there in the field, When the judge calls, they have to listen, right? It's the EF Hutton
Yeah, yeah.
scenario.
I don't know what you're talking about. All right, I think that was the last question. Anybody, any closing remarks from anybody else? All good?
Oh, good.
Okay. All right, thanks everyone for joining. We appreciate it. Hope you got some value out of this, and we'll be talking soon. Have a great day.
Thank you.
Thank you.